Welcome to the Planit Smart Scheduling demo alongside Priority software. Let's dive into the future of advanced planning and scheduling.
I'm Toma and I'll be presenting Planit. Planit is a software we developed that helps with scheduling tasks on resources along a timeline alongside information systems. Most uses of Planit are in the field of production planning. Planit serves as a tool for production planners in an industrial plant. There are also other applications in the fields of distribution planning and organizing work or scheduling tasks for service personnel. But most of Planit's applications and most of our expertise are in the field of production planning. This is also called APS, Advanced Planning and Scheduling. As you can see here, Planit serves close to 100 customers today in various industrial sectors. You can get an impression from the factories and the industry. The main benefits of using Planit are shortening the time required for production planning, increasing production efficiency, preventing waste, avoiding unnecessary changes on the production line, improving on-time delivery to customers, enhancing control over the availability of raw materials, and preventing malfunctions due to lack of raw materials, whether within the processes or materials coming from external suppliers, and of course, improving internal organizational communication between the various departments, which also leads to greater efficiency. All of this is achieved while maintaining transparency and stability of the plan. Among all the customers presented here, most of them use Priority software. In Israel, Priority software is the leading ERP, and we also operate mainly in Israel. We also have several implementations abroad in the United States, in England, in Romania, and in Europe. Most of our implementations are with Israeli companies that have factories abroad, but there are also several implementations directly overseas. Our relationship with Priority has deepened significantly over the years, to the extent that we have actually become technological partners of Priority software, and anyone who visits the Priority software website will find us under Priority Marketing, all of our products, mainly production planning. The collaboration is also reflected in the fact that Priority created the connector, not just for us, but for everyone, and we are part of it. This connector essentially allows for a highly organized and exceptionally secure interface with the entire system. In fact, we actually receive a unique special access key directly through Priority's internal license table. If you look under the section for licensed applications, you can clearly see us listed there with our specific connector, along with a detailed list of all the various entities we are authorized to access. For example, consider the work order screen, which is a module we can both read data from and write information back to. Furthermore, we have the capability to update the promised date in a customer order. We can perform comprehensive production reporting, and we can also retrieve any specific data as needed for your operations. Of course, for each implementation, it is possible to decide to block certain entities or to open access to other entities as needed, and at Priority Software, we cooperate accordingly. We work together on this so that the customer ultimately receives one complete integrated solution, and in fact, Planit becomes a continuation tool for Priority. All the data you see in Planit is Priority data as we implement it alongside Priority. So this is Planit. Essentially, here we see Planit, which is of course a web-based system. It is cloud-based and designed to work in the cloud, although many industrial customers prefer to install it alongside Priority at the customer site on the customer server, and that is possible. Of course, we recommend installing it in the cloud, and we have developed the software so that it is fully adapted for the cloud. Many applications for numerous customers run on the Planit cloud, and it is secured at the highest level according to all standards. Similarly, the connectivity to Priority is also done securely, according to the highest existing standards. What is Planit? So Planit, as I mentioned, is a planning board, a planning tool. In all Planit applications, we will always have resources. In the manufacturing world, these resources are usually production lines or machines. Sometimes they can also be workbenches or assembly tables in the factory. And the blocks we see here are the same tasks that need to be performed on the lines. You can see the arrows that lead from one operation to another, and essentially these arrows represent the routing that an item goes through between the different production machines. There are also places where you see several arrows converging, which means that here we have an assembly of an item. There is a joining of several sub-work orders into an assembly work order, and this is how the finished product is created. Of course, what I'm showing here is just an example, and it's only one example out of many. In industry, there are different factories They are structured differently. Some are built in this way where production is actually done in stages and is complex. Sometimes it's structured or done differently, each according to its own industry. So as I mentioned, the connectivity to priority is reflected in the fact that the resources are actually the work centers in priority. If we go here to the screen, to the modeling menu in priority and enter the production and modeling section of the system, we'll see the work centers. I'll go into the production menu here, factory modeling, and then we see here the work centers, the items, the operations, the routings. All of these things are transferred to Planit. Here I have the work centers screen open, and we can see the production lines, cutting 1, cutting 2. And here they are exactly. We control them from priority. For example, we control their display order in Planit. In Planit, we use as many of priority's standard fields as possible. For example, here there's a column that defines the display order. You define the production lines in priority, and here they appear in Planit. The blocks we see here are actually operations in the work order from priority. Behind each of these blocks, behind each such operation, there are many details. We can view this in different ways, whether it's what we display on the block itself or what we show in the window that opens like this. There is also another screen of additional work attributes that can be brought up to view more information. We can collect from priority all the information relevant to the planner and present it in an accessible way, whether it's quantities, dimensions, various attributes of the item, item description, customer description, product description, and any other relevant information. The same goes for dates. We're interested in the delivery date, the required date. Every planner always wants to know these dates, and they are a central consideration in planning. So essentially, we bring all the information from priority to us. Once the information has arrived in Planit and has been loaded, you can then use the tool to manually edit the plan. We'll soon see additional options as well, but here I am moving the job from place to place, and the system immediately recalculates the queue status in real time. Okay? Unlike the MRP system, which basically takes an order, explodes it from end to start, and creates backward requirements for us, but doesn't actually plan what happens on each of the lines. This is called infinite capacity planning. In practice, the queues are not actually planned. In contrast with Planit, we definitely bring in the operations and plan job queues. You can't just stack one on top of the other and think that's okay. Planit immediately arranges it in a queue, pushes the job, and moves it accordingly. So in effect, we have a planning tool with finite capacity. So here I make manual adjustments, and the queue immediately adapts itself. You can also instruct the system, and it's designed for this, to schedule automatically. How does it schedule automatically? For example, we can tell the system to remove all the jobs, to completely clear the scheduling board. I'm telling the system to remove all the jobs. All the jobs are taken out. They're outside the production lines, except for those jobs that are currently actually on the lines. And maybe we can also decide to lock some of the jobs in place, because for today's schedule, we don't want it to change. Now I'm going to ask the system to reschedule all the jobs. It's possible that new jobs have been added as well, new orders that have come in, we schedule them, and the system basically performs optimization and rescheduling for all the jobs. Right now, this process happened pretty quickly because we're here in a demo system with only 100 jobs. Such a process can take 10 to 20 seconds or even up to a minute in cases where we have 4,000 or 5,000 jobs in the system. And in this way, we received an automatic assignment with optimization where the planner can review the result, and based on the automatic outcome, they can still make adjustments. We make sure the planner doesn't make major mistakes, for example, not assigning a job to a place where it is completely forbidden to be. That is, we are operating here within a protected environment, helping the planner avoid making major mistakes. And we still use optimization while also allowing for responses and manual actions. On what basis did the system assign tasks? And on what basis did it perform the optimization? We defined a cost mechanism that essentially assigns a score to each job wherever it is placed. This score always consists of elements such as time, meeting delivery deadlines, and balancing across the timeline between the different lines. Mainly in this area, but there are additional parameters that can be included, such as setup costs for changeovers on the line. In many industries, there is a desire to keep the same type of material on the line continuously in order to reduce those setups and changes. There can also be various constraints or preferences For example, sometimes the production rate differs between lines, and sometimes there is a particular preference. All of this can be reflected in the costs. Once we've factored this into the costs, the system will try to schedule more effectively and will learn the best situation for the customer. If there are production reports, we can also use those reports as input data for the next automatic scheduling with more up-to-date times and a better connection to reality. That's how the optimization works, and that's also how we can control and influence it. Together with the customer, we decide which factors participate in the optimization and which ones we want to take into account. We also help the customer control the order in which jobs are submitted. Sometimes it's not just the costs, but also the submission order that will affect the quality of the automatic scheduling and the optimization. So I talked about connectivity, I talked about automatic scheduling and about choosing actions, whether manual or not. You can see in the background here this gray patch. Basically, we also have a layer of availability. We can define at which times work centers are, say, under maintenance or unavailable, or of course during weekends, and these instances of unavailability will actually determine the duration for us. And if necessary, we will estimate the duration of the work as the duration of the unavailability, with the goal being to create a picture that is as realistic and accurate to reality as possible. You can see the different colors we display here for the tasks, where purple, for example, indicates that we have a work order, light blue means we only have a customer order, and there is not yet a released work order. It could be an unreleased work order or even a task based on customer orders, so the color indicates that. And the reds we usually use to alert that something is not on schedule and requires the planner's attention. These blue colors represent that this particular task is currently on the line and actually active. You can see that the required quantity is 100 and already 80 units out of the 100 have been reported. You can see this on the label. You can also see it by the color on the outside. This task, on the other hand, has already been fully completed, and that's why its color is light blue. You can see in the quantities that 100 were required and 100 units have already been reported at this stage. In this example, the production reports were entered in priority in the usual places under production, production control, and from there we have the production reports. In the standard priority systems, reporting, production reporting, and these production reports are immediately sent to Planit as well, since, as I mentioned, Planit sits on top of priority and its data. When we make changes in Planit and want priority to be aware of them as well, all we need to do is save. Saving causes us to move from a planning mode that is offline, disconnected in real time from the system. The moment we click save, the data is saved back into the tables in priority, including updating the times in the work order, for example. And from here, even if you want to make updates, it doesn't happen automatically. But let's say the delivery date is guaranteed to the customer. That can also be done from within Planit. Every block we see here, as we said, is part of a work order or part of a task. You can double-click to enter and view the task details, see which order this task is related to, what the header data is, the actions, and also the components, if there are any. We will see them down here. For example, if we take the assembly tasks, then in an assembly task, we will also see the components listed below. And in red, we will receive various alerts regarding availability. I will address this shortly, material availability. But this screen allows us to see that we have the option to create diverse screens with different displays, tables, and texts, and in this varied way, with different actions available directly from the screens, in a very flexible way, which allows us to do special things for our customers. So that's regarding the different displays. You can see the various arrows that really show us the connections between the tasks. We can relatively easily filter all the related tasks, and in this way we can really see the progression of the work order, almost like a project, but actually it's a production work order and all the connections between the different operations and also between the various levels of the manufactured products tree. Okay, so that's this format. We can filter data as we wish within Planit. You can select any work attribute, focus on a specific item or a particular customer, and highlight just that. In this way, I'm highlighting only the chair of type 1, and here are all its occurrences at every station. This is how it looks on the assembly lines, as I demonstrated. A specific item. In addition, you can also filter things that are programmed. For example, if I want to filter all the orders that are overdue and are hosting, so for that purpose, we created a button that does this and immediately filters for us all. You can see absolutely all of the specific customer orders that are currently sitting in a critically delayed status. And in this way, you can easily highlight and bring to each individual person the relevant things that specifically interest them. Right here, I am carefully demonstrating exactly how the delay filter works in this scenario. Here, all the overdue jobs are highlighted for us in red, okay? And the filter is activated. And this is an example of the filters. This view that we're seeing right now we call it the Gantt view, a display where you can see the resources and the timeline at the top. The timeline, you can change the zoom in and out, jump to today, go to the edge of the range, or jump to a specific date. You can easily zoom in and out from here and also adjust the view to preset displays, for example, a work week view. So here we can see a week, a month, or a specific day, each according to the resolution that interests them. In addition to the Gantt view, we also have a list view. If I, for example, double click on one of the resources, I get the data in a list format, a bit more similar to Excel, like many people are used to working with. Of course, in the list view, you can see more details on one hand, but on the other hand, you don't really see the overall picture and the workloads. You can also integrate these different visual perspectives when the screen is split. For example, we can showcase the exact same comprehensive list of tasks at the bottom of the interface. This specific configuration, positioned underneath like this, effectively allows the planner to actually see both a high-level overview alongside a much more granular, detailed perspective of every single task. Specifically, in this way, we can close the window and see both screens like this. You can make additional splits as well. Another view available here is the load view, machine load, a display somewhat similar to BI. It's important to note that unlike BI, the data here is directly related to the plant. When we move a job from one place to another, the load display immediately changes accordingly and adapts itself, and in this way, the system provides further assistance in decision making. We can see that the load on line 3 is gradually decreasing compared to the other lines in this way. Of course, you can also see this in the Gantt chart, but this is just another way to look at things. This is not meant to replace BI. It's intended to provide additional information alongside the actual planning process. In addition to this dashboard screen showing the loads, you can also view a load graph. A load graph can be useful when we want to sum up a certain value over the timeline. Here, for example, we've brought up a load graph of employees that we want to monitor, and we can also actually link the different screens above and below. When we move the graph above, we can also move the graph below accordingly and see the result with the system alerting us if any kind of peak occurs. At a certain point where we actually won't be able to cope unless we change and adjust the plan. So that's regarding these types of views. There are also additional features here. I won't go into all of them, but this is how the work is done using Planit: manual adjustments, automatic scheduling, using the different views, transitions between the systems. It's very easy to switch from Planit to Priority. You can select a specific action and tell the system to take you now to the work order in Priority, and the system navigates directly to the relevant screen in Priority and opens the work order for you. In this way, the workflow can be very convenient and fast when moving from Planit to Priority, doing things in Priority, and then returning to Planit to continue planning. Scheduling techniques are used by planners in the system in different ways. In fact, there are factories where MRP is run in Priority. The MRP essentially creates the work orders for us, and then we come and plan them in Planit. That is one mode of operation. Another mode is planning based on customer orders, which is more suitable when a factory produces according to orders. In this case, we can actually see the orders waiting for us to plan, which we have not yet scheduled, and from this screen, we can create tasks. The concept of a task was created in order to distinguish between tasks before they become work orders. In fact, these are planning tasks. And once we are satisfied with the result and the plan we have made, we have extracted tasks from the orders and carried out the planning. You can see these blue ones, which are actually tasks without a work order. And from here, once we decide that we like this plan, we can tell the system, create a work order now, and it will immediately enter the work order and create it through the interface as a built-in feature in Priority. And in this way, we adapt ourselves to different planning styles and methods that are characteristic of every industry and of each factory as it has developed. Overall, we try to support the processes and not to impose any particular planning method of our own, but simply to serve the approach that exists in each and every factory. So that's regarding the different planning methods. I'll talk about one more topic, and that's the issue of raw material control. Control over raw materials. This control is achieved by the fact that we are actually connected both to the product tree and to the purchase orders and inventory. And through these, we can, based on the production plan, carry out a procedure that monitors, essentially scans, the entire production plan and understands when each item is needed. And it creates a material balance for each of the production components, whether they are work-in-process products or purchased raw materials. Then we can immediately get a screen that shows us the exceptions for each of the materials. We can go in from here and drill down into the material to understand what the problem is, or we can also see the result in Planit itself, for example, on the assembly lines. We can go here into one of the jobs in the task details. Here we will get the exceptions. I'll focus specifically. The red ones indicate that there is a problem. If I look specifically at the screws here, I can look at one of the screws, see that I am currently here, and indeed there is no alert, but later on this screw will be missing, and apparently a purchase order needs to be added here in order to include it. If I take, for example, the second screw, not the first one, I can see that here, for example, in this case, we have a purchase order that is scheduled for a future date. Right now, we are at this inventory level. These are the consumption points from the various work orders. Here is where the purchase comes in, and here, on this date, we are already expected to reach the red zone. It shows us that from this point on, we will also be in shortage of this material, and action will be required, either to add a purchase order or to postpone production further. Move the production here beyond the currently existing purchase orders. So, in this way, this tool enables material control. We call it material control. It's not a replacement for the MRP, it's alongside the MRP. The MRP is what runs at night, and it takes a long time, and you can't run the MRP many times during the day. It's a very heavy process. In contrast, the material control can be run relatively many times. It's a short process. As you can see, it also does less than the MRP. It doesn't generate purchase requisitions. It doesn't create work orders. It only shows gaps relative to the existing plan. That's why we called it raw material control and not an alternative MRP. The material control can also be used by production planners to ensure that they are sending feasible production plans, but also for the purchasing staff who can look at and understand what the plan says and respond to it, whether it's necessary to expedite purchase orders or to talk with the production staff in order to coordinate and decide what to do in these exceptional cases. So, this topic of material control is also a central and important tool in our system. So that's it for this overview. I showed more or less what Planit is, what the Planit tool is, and how planners work with it. We saw the connection to the priority data model under the production module. Here we have integrated the Planit module so that the system can be operated. These screens are required in order to operate the system, and they are an integral part of our installation when we arrive at a new client. The collaboration with Priority is a deep one, reflected also in the unique licensing model with the special licenses and commercial agreement, the connectivity between the systems, of course, and the interoperability. That's it for this presentation. Thank you for listening.